Hi there everyone. I'm just going to do a short video on synthetic division, and so I'm just going to run through the steps, give you an example, and let you know how easy this really is. It's a shortcut for long division. I don't know if you are aware, I've done a long division example right here. This is long division, polynomial long division, and synthetic division is a shortcut for that. So let's take a look. There's a few things that need to happen in order for this to work, and the first thing is the polynomial, and so that would be this one right here, x cubed minus 8 in our example, must have every single term from the leading term all the way down to the constant represented. So as you can tell here, there's no x squared term and there's no x term, and so what we have to do is we have to include those, and we give them each a 0 coefficient. So yes, the zeros are important, and it looks like this, okay? Once you've understood that your polynomial has to look like that, then what we do is we focus on the coefficients. And the coefficients here, of course, would be, in this case, 1, here, 0, 0, and negative 8. So we're going to use those coefficients a little bit later. Now, the other thing is the divisor, okay? What we do is that we have to identify, and we're going to be given binomial divisors. Most of the time, this x is going to have 1 as a coefficient, so we don't have to worry about anything like that. So this is for a simple, straightforward beginner one. And when you have x minus 2, for example, the format is, this is a binomial in the format of x minus a. So x minus 2, a is going to be positive 2. Okay? So whatever this sign is, shortcut is, just flip that sign, write the same number. So a is positive 2 here. Okay, so what do we do next? Now that we've got this identified, we draw an elongated L. It's the best way I can use to explain it. An elongated L. And remember these coefficients from before? Well, what we do is we put those coefficients along the top row inside the L. So we're going to have 1, 0, 0, and negative 8. Also, the A is to the left. Oh, so that's 2. So we're going to put 2 down here, and that's the left. Now, it doesn't matter where on the left it is, but we just put it outside of the elongated L. The other thing that I like to do always here that you might not see in other textbooks is to put a little box right here underneath the last number. Okay, so now we're set up for synthetic division. And of course, what this is doing is it's a shortcut for this long division polynomial, polynomial long division. And so this is how we do this. We drop this first number down. Always you drop it down beneath the elongated L. Always just whatever this number is, drop it down. And now the cycle begins. We multiply. So this is multiply. And the product we put up here. So 2 times 1 is 2. Then we add. 0 plus 2 is 2. And that is one complete cycle now. So now we start over again and we multiply again. 2 times 2 is 4. Add 4. 2 times 4 is 8. Add, and finally you put the sum in there. And this being a 0 is important because that means that the remainder in this division, synthetic division, the remainder is 0. Therefore, we can know that x minus 2 is a factor of the original polynomial that we have here, x cubed minus 8. This is an actual factor. There's no remainder left over. And so, how do we interpret this now? Okay? So the 0 is the remainder, but what about the rest of these numbers? The quotient, these numbers right here represent the coefficients for the quotient. Now, if this polynomial is degree 3, that means the first term is an x cubed, this will always be 1 less. So this is going to be x squared, this is going to be an x, and that's going to be a constant. So this is a plus 2, so that's plus. Here is a plus 4, so that's plus there. And that is your actual quotient, and with the number in the box being the remainder. So your answer is simply x squared plus 2x plus 4, and with the remainder of 0. And so how would we check that? Well, if you multiplied the divisor by the quotient, you should get the original polynomial of x squared minus 8. And so if we're going to test that, let's do some, we got to do some expansion here. So distribution. And so we have x cubed plus 2x squared. I'm going to go a little quicker here. Plus 4x minus 2x squared minus 4x minus 8. And when we simplify that, we don't have any other x cubed, so that comes down. The 2x squared is going to cancel off with the negative 2x squared, and the positive 4x and the negative 4x. So you see what we have here is we have a result of x cubed minus 8. So therefore, we've done everything correctly, and this indeed is your answer. So that's synthetic division in a nutshell. And again, whatever you get in the box here is the remainder. And when you're studying the factor theorem, if this is a 0, you know that the x minus a here, so in this case it was x minus 2, and this right here, these are both factors of the original polynomial. So that's synthetic division. Hope that helps in your studies.